Okay, we're going to start talking about the actual surface areas and calculate actual surface area. And the first thing we're going to do is we're going to talk about prisms. Okay, first of all, we've got to know what a prism is. We're going to go back and review this and let you know what a prism is. Prism is a solid figure, geometric solid figure, that has bases and lateral faces. Well, how many bases it has? It has two congruent surfaces or polygons. Okay, it's a 3D solid, geometric solid that has two congruent surfaces and polygons. Now it also has lateral faces. These are the surfaces that are not bases. They're not bases. So we're going to use what we showed you in the last lesson in 12.1. We're going to use these models. Now, we're looking at this thing, and what we're looking for is we're looking for the bases. Now I have 1, 2, 3, looks like squares. And I have 2 triangles. Now, based upon these definitions, what do you think are the bases and what are the lateral faces? Okay? I want two bases that are congruent. Two surfaces that are polygons that are congruent. Only two. Well, the two sides that are congruent are the triangles. So, the name of the prism, let's put that up there. Shape gives name. Shape of base gives, we don't want a capital there, let's go, gives prism name. Name. Okay, so the shape of the base is going to give the prism its name. What's the shape of our bases? Triangles. More importantly, it looks like an equilateral triangle. So this would be known as an equilateral triangle prism. Okay? It has two sides or surfaces that are equilateral triangles. Now, the other surfaces are called lateral faces. It so happens that all of our lateral faces are also squares. There are equilateral quadrilaterals, rectangles, equilateral rectangles, and also rhombus. Okay? So they are surfaces that are not the bases, are the three squares. Now, lateral edge, it's where lateral faces meet. Lateral faces. This is a lateral face, this is a lateral face, this is a lateral face. This is a lateral edge. It's where lateral faces meet. This is not a lateral edge. Why? Because that's not where lateral faces meet. You got it? This is where a base and a face meets. Okay? A lateral face meets. This is a lateral edge, this is a lateral edge, this is a lateral edge. Now, it has 3 points or vertices. Has 3 on one base, 3 on the other base. So how many vertices does it have? Total of 6. How many lateral faces does it have? Has as many lateral faces as it has lateral sides, okay? How many lateral edges does it have? It has as many lateral edges as it has lateral faces. So if it has 3 lateral faces, it's going to have 3 lateral edges. Okay, now how many total edges does it have? Well, I've got 3 here, I've got 3 here. I'm going to have 1 edge for each face, so a total edges, not just lateral edges, but total edges, it's going to have 3, 3, and 3, or this one's going to have 9. Let's look at this one. Another prism, okay? We're looking for 2 sides that are the same. What 2 sides are the same? Not hidden. The 2 hexagons are the same. Happens to be an equilateral hexagon, a regular hexagon. Therefore, the 2 congruent surfaces or polygons or hexagons This shape of the base gives the prism the name, so this is a hexagon prism or a hexagonal prism or hexagonal prism. Okay? Now, what is the shape of the lateral faces? So happens because we have a regular hexagon as its base, these are rectangles. All of them are congruent rectangles. Okay? Those are our lateral faces. Lateral edges, how many sides do we have? How many lateral faces do we have? We have 6. So how many lateral edges will we have? We will have 6. How many edges will we have around the base? 6 more. How many edges will we have around the base? 6 more. 6 plus 6 plus 6 is 18 edges. How many points will we have of vertices? We have 6 around that base, 6 around that base for a total of 12. Now, let's talk about the altitude of height. The altitude of height is a perpendicular distance between the bases. Oh, bases, the hexagons. What's the perpendicular distance between the bases? Now, we talked about oblique or right prisms or right solids. This is a right solid. Why? Because if I were to connect the center of the bases, they would be perpendicular to those bases. That segment would be perpendicular to the bases. Therefore, the altitude would be the length of any one of the lateral edges, because the lateral edges are perpendicular to both bases. Okay? The lateral altitude or height must be perpendicular distance between the bases. Okay? If you have an oblique prism, then you have to do and draw and measure and determine the perpendicular distance between the bases. Okay? All right. So we're talking about that. Now, let's talk about surface areas. We have something called lateral surface area. Lateral surface area is just that. It's the area of all lateral surfaces. Huh? What do you mean? Just what I said. Only of the lateral faces. It does not include the surface area or the area of the bases. When you say lateral, that means lateral surface area. Okay? That's all it means. Okay? The surface area of the lateral surfaces are the lateral faces. Alright? Area of all lateral surfaces are lateral faces. That's the sides, not the bases. Okay? Now, what's TSA mean? That's the total surface area. It's the lateral surface area plus the area of both bases. Okay? So in that case, let's talk about this. LSA would be, in this particular prism, would be the area of all of the squares. Why? Because they're not the bases. They're the lateral faces. Alright? So LSA would be the lateral surface area, or the surface area of all of the lateral faces, the squares in this case. TSA would include the area of both bases, both triangles, and the LSA, or the lateral surface area. We would add all of that together. Alright? In this case, the LSA would be the surface area of all of the rectangles that make up the lateral faces. LSA. That would be the surface area of all of the rectangles, because the rectangles are the lateral faces of this hexagonal prism. TSA would include the area of both bases and the lateral surface area, or the total surface area. Okay? Now, if a problem does not tell you what it's looking for, if it does not say lateral surface area or total surface area, all it says is surface area, there is a rule that says, oh, if all they're asking for is a surface area, they mean total surface area. In order for you to calculate just the lateral surface area, they have to say, what is the lateral surface area? They have to tell you they only want the sides and not the bases. Okay? They have to tell you, I only want the lateral faces. If they don't tell you, all they say is we want the surface area, they mean the total surface area. Alright? Let's look at equations. LSA, the lateral surface area, equals capital P times H. What's capital P? Capital P is the perimeter of a base. So let's look here. So in order to calculate the lateral surface area, I've got to know the perimeter of the base? Yes. You have to know how far around it is one base. Of a base. One base. Have to know the perimeter of one base. That's big P. And you have to know the height or altitude of the prism, or the perpendicular distance between the bases. Remember, if you have a right prism, that is the length of one lateral edge. Why? Because that lateral edge is at perpendicular angles, or right angles, to the bases. Okay? So P is the perimeter of one of the bases. H is the perpendicular distance, or the altitude between the bases. Okay? Again, on this one, P would be the total perimeter of this hexagon. Okay? Capital P would be the total perimeter of this hexagon. H would be the perpendicular distance between the two bases. In this case, in this right hexagonal prism, that would be the length of one of these edges. All right? Let's go on. Now, total surface area equals LSA plus 2B. What's B? Area of one base. So the total surface area is going to be the lateral surface area, plus the area of the bases. How many bases are there? There's 2 of them. So we need 1 for each one. So total surface area is capital PH plus 2B. 2 capital B. So the perimeter of a base times the height plus 2 times the area of one of the bases. That will give us the total surface area. There's a lot here, a lot of definitions we talked about. This is some of the most important stuff you'll know about prisms. The bases are 2 congruent surfaces or polygons. That shape of the bases, the shape of the base, gives the prism name. Okay? Gives the prism name. What's a lateral face? Surfaces that are not bases. Okay? What's a lateral edge? Where lateral faces meet. Altitude or height, the perpendicular distance between bases. If you have a right prism, this will also be the length of one of the lateral edges. Lateral surface area, LSA, lateral surface area, it's the area of all lateral surfaces. Does not include the bases. TSA is a total surface area, LSA plus the area of both bases. Okay? If they don't tell you what they want in a problem, then you are to calculate the total surface area. If all they say is calculate the surface area, you are to calculate the total surface area. LSA equals capital P times H. That is the perimeter of a base, one base, times the height or the perpendicular distance between the bases. TSA, total surface area, is LSA, or lateral surface area, plus the area of 2 bases, or 2B. Capital B is area of one base. So TSA is capital P times H plus 2 times capital B. Okay? Let's try some problems.